Next method we're going to look at for factorization is called grouping in pairs. And this method will only be applicable to expressions that have 4 terms in them. And as the name suggests, to do this method we're actually going to group those terms into pairs. So these first two will be grouped together, and the second two will be grouped together, and we're going to think about each as a separate factorization method. Before we do that though, we have to do what I suggested in the last section, and that is always try highest common factor factorization first. So let's have a look here. Are there any terms, or are there any factors that are common to all 4 of these terms? Well, there's an A in 3 of them, but it's not in the last one, so that's not a common factor. However, if we look at the coefficients, both of these are divisible by 3, both of these are divisible by 3, so what I can actually do is factorize a common factor of 3 out the front. And it's important that we always get into the habit of looking for that before we do anything else in our problem. Okay, 27 divided by 3 is going to be my 9 here. Once we've done that, now we're ready to do grouping in pairs. So we're going to group those terms like this. And we're going to factorize each of those as if it was its own separate highest common factor problem. So for the moment, I've kind of got tunnel vision on. I'm not really thinking about this 3, and I'm not really worrying about the brackets. I'm just dealing with what's inside the brackets. So right now I'm going to ignore this part here, and I'm just going to focus on the a cubed plus a squared and ask myself, what's the highest common factor of those 2 terms? Hopefully you can see that that's going to be a squared, and a cubed, when I factorize a squared out, I'm going to have an a left over. A squared divided by a squared, that's just going to be 1. So this first one, this first half of the problem, is going to factorize to a squared outside of a plus 1. The second part, negative 9a minus 9, it's pretty clear to see that there's a factor of 9 that can be factorized out there. And in fact, I'm going to take a negative because both terms have a negative in them. So I'm going to take negative 9 out the front. I'm going to be left with an a and a plus 1. Okay, now at this next step, it kind of looks messier than what it did at the start. But things are about to get a little bit neater. What I'm going to do is I'm going to think about this whole a squared here as one clump, as one term. Okay, so I'm treating it as if it was just an x or a y or some pronumeral, but the whole a plus 1 is what I'm thinking of as one sort of unit. And you'll notice that there's also an a plus 1 over here. And with any grouping in pairs problem, okay, any problem like this, we will always rig it so that this happens. We'll always make sure that when you do this grouping in pairs, you'll get the same term come out in the brackets. Okay, the same expression in the brackets in both terms. Now what I'm going to do, I'm still kind of ignoring this 3 and the outside set of brackets. I'm just concentrating on this middle part. If that was just a b or something, so if I gave you this problem, a squared b minus 9b, and said factorize that, it'd be pretty easy to see that I could pull the b out the front. Okay? In this case though, I don't have a b, I've just got an a plus 1, the yellow thing that I've highlighted here. So what I can actually do is, just like I can bring the b out in this situation, I can bring that a plus 1 out the front in this situation. So a plus 1 and a plus 1, they can both come out. In this first term, I've got an a squared left over. In this second term, I've got a minus 9 left over. And if we have a look at this expression here, there's actually a redundant set of brackets. This set of brackets here, the outside set of brackets, they're actually not doing anything. They're telling me I've got to do this bracket times that bracket before I do the 3 times it, times whatever the result is. However, we know that with multiplication it actually doesn't matter what order we do things in. I've got a 3 and I've got an a plus 1 and I've got an a squared minus 9. Each of those 3 things have to be multiplied together, and it doesn't matter the order. If I want, I can do the 3 times the a plus 1 and then this one. So this set of outside brackets, while they're telling me to do this multiplication first, whether I do it or not will not affect the overall result, the overall value of this expression. So I can actually just leave that redundant set of brackets out, and I'm left with this expression here. Now, this is actually not as fully factorized as it can be. This last part here can actually be factorized further, but to do that we're going to have to look at another method called the difference of two squares, and we'll come back to this problem in a couple of videos and deal with how would we actually factorize this last part further. But as far as the grouping in pairs goes, this is as far as we can go with that method.